Okay, now in this video, you want to solve questions on the uniuyo mth111 past questions under the roots of a quadratic equation. So I'm just going to select question that concerns solving for the roots of a quadratic equation. Then I'm going to solve them here, alright? But first, let me give you some things that we will need, alright? Some facts that will help us to solve problems under that. So when we have a quadratic equation, where the necessary power here is just x squared and is the highest actually, and the coefficient there should be non-zero, right? That is, a should not be 0. So such an equation is called a quadratic equation. So we say, in other words, quadratic equation is a polynomial equation, or it's a polynomial equation with degree 2, alright, and the coefficient non-zero, alright. Now, again, if we solve such an equation for the values of x, so we're expected to have two values for x, okay, either repeated values or just real and distinct or even complex values. So, if alpha and beta are the roots of the equation, in other words, if alpha and beta are the solutions to such an equation, such that when you plug in alpha for x in this equation, it gives you 0, and we plug in beta for x in this equation, it also gives you 0. So those things are called the solutions or the roots of that equation. So if alpha and beta are the roots of the equation, it means that if you add them together, alright, and take the negative of their sum, then it should give you b over a. It should give you the coefficient of x divided by the coefficient of x squared. And if you multiply the two roots together, you should have the constant term c divided by the coefficient of x squared. So we're going to use these two equations, alright, a lot of times, in fact, almost all the time. Okay, so, but noting this, it means that if we divide this particular equation through by a, alright, we'll just have here 1 as the coefficient of x squared, here we'll have b over a, here we'll have c over a, alright, if we divide through by a. So when we do that, this is what we get. This is just c over a. This is c over a, like that, alright? So we divide through by a, this is what we get. It means that in place of b over a, we can simply put negative alpha plus beta, alright? And in place of c over a, we can just put alpha times beta. So that means that the product of the roots will give you the constant term divided by the coefficient of x squared, and the sum of the roots, the negative of the sum of the roots, will give you the coefficient of x divided by the coefficient of x squared. So I'm just going to use this fact, and we are going to go ahead and solve as many problems as possible. Okay, so let's move over to the first question. Now from the first question, we're given that if alpha and beta are the roots of this equation, then determine the value of this product, alpha minus 1 squared times beta minus 1 squared. So, if alpha and beta are the solutions, just like we have here, okay, alpha and beta, so all we need to do is to establish the fact that since alpha and beta are the roots, it means that alpha plus beta will become, now look at this, you know that minus the negative of alpha plus beta is b over a, okay? So if I multiply both sides by negative 1, I'm going to have that alpha plus beta is negative b over a, right? It's the same thing. So it just means that their sum will give us negative b over a. So we need to know what b is. We need to know what a is as well. And again, we also know that the product alpha times beta will give us c over a. So we need to know b, a, c, a. So from the given equation, we see that a is the coefficient of x squared, just like we have here, alright? And b is the coefficient of the x, just like we have here, and I'm just going to make use of that. So c is just 1, alright? The constant term, just like this. Okay, so from there, I can just say that we know a is equal to 1. No, the coefficient of x squared here is just 1, right? Just 1 like that. We know that b is negative 2, alright? It is supposed to be plus b. So plus b is just plus negative 2, which is just negative 2, alright? And c is 1 like that. So that means that here we're going to have alpha plus beta is b over a. So that is negative of b is negative 2 over a, which is just 1, alright? So you are saying negative of negative 2 over 1, that is just positive 2. Okay, that's clear. And again, this is C is 1, so it's going to be 1 over, okay, let me just put it down in red. C is 1 over 1, which is just positive 1 like that. So C is negative 2. Since we have negative already, being multiplied with the whole fraction, alright? So we just get it to be positive 2 and so on, where A is just 1. Alright, so since that is the case, then it simply means that alpha plus beta is 2 and alpha times beta is 1. So we can look at this as two equations, alright? And we want to solve this simultaneously. So I go ahead and call this one, circled 1, and I call the other one just 2, circling it. Alright, so I'm going to go ahead and solve these two equations for the value of alpha and beta. The idea is that I just want to get the values of alpha and beta so that I will put them into this expression and I will just simplify things, alright? Okay, so we can from equation 1 get something for 2, alright? I can from equation 1 say that alpha is equal to 2 minus beta. Okay, so from 1 in blue, okay, it means that alpha is equals to 2 minus beta, that is by just subtracting beta from both sides. Okay, so we're going to substitute that into equation 2. So let me just substitute straight. In place of alpha, I'm going to put 2 minus beta, and we're going to have 2 minus beta times beta here, alright? So this is just the for the alpha. So 2 minus beta times beta is equal to 1. So just multiply this, we're going to have 2 beta minus beta square is just 1 like that, alright? Okay, so from here, I can see this as a quadratic equation. In fact, let me rewrite it very properly. We're going to have that beta square minus 2 beta is equal to 0. This is plus 1. Alright? Okay, equal to 0. That is plus 1 equals to 0. Like that. So given that alpha equals to 2 minus beta, we just substitute that, we get this for beta. And if you just want to compare this with the original equation, you see that they are the same except for the beta in place of x. Okay, so let me see if I can factorize this. So I just want to get my values of beta. Okay, if I can factorize this, then we are going to have that beta minus 1 times beta minus 1 is equal to 0, right? You know how to do factorization by just thinking of two values whose product will give us the product of this term and this term. So the product will give us b squared and 1, and whose sum will give us this negative 2. So by just doing that, I see that if I multiply negative 1 with negative 1, I'm going to have positive 1. And I add those two things, I'm going to have negative 2, alright? So that is why I'm putting negative 1 here, negative 1 here, provided the coefficient of this beta square is just 1. So you learn how to do a factorization method for any quadratic equation. So from here, we can see that the product of these two terms, which are in fact the same, is giving us 0. It means that beta is equal to 1. We can put it down like this twice. So the values of beta is 1 and 1. So it's a repeated value. Okay, so since beta is equal to 1, this is what it means. In place of beta here, I'm just going to put 1. That means 1 minus 1 is going to be 0. I square that, is still 0. And multiply it with this other thing, it will be 0. So the value of this already is going to be 0. There's no point going for alpha again, alright? But we can still go ahead and check for alpha and put the two things back, provided they are correct. It's still going to give us 0. So we remember that alpha is equal to 2 minus beta. That means that to solve for alpha, we're going to make use of that. Alpha is equal to 2 minus beta. And we know that beta is equal to 1. Alright? So where beta is 1, beta is just 1. Okay, that means that alpha is going to be 2 minus 1 like that. And what do you see? Alpha is just 1 as well. So plugging them into this, we're going to have 1 minus 1, and we square that, times 1 minus 1, and we go ahead and square that, where alpha and beta are 1. So we just substitute those values backward. So here we're going to have 0, and here we're going to have 0. So that means that the result from this expression is just equal to 0. So this was a very simple example. Okay, let's go over to the second example. It's going to be a little bit tricky, but it's still going to be simple, alright? Okay, so over to the next question. Now for the second question, we have that if alpha and beta are the roots of this equation, x squared minus 3x plus 4 equal to 0, then we should find the equation whose roots are 1 over alpha squared and 1 over beta squared. So from here we know that a is 1, we know that b is just negative 3, and then c is 4, alright? Okay, so b is negative 3 and c is 4. Let me just put this down. Okay, so what I want to do here is that I would just like to use the facts that we know that the sum of the roots will give us negative b over a, and the product of the roots will give us c over a. Then I will use these new roots, okay, to find a new equation. Now, by using these new roots, we know that the sum of the roots of a certain equation will give you negative of b over a of that equation. So, to find the equation whose roots are this, and this, it means that the sum of these two roots will give you negative b over a of that new equation, and the product of those two roots will give you something new, right? The only thing is that they relate with this given equation in terms of alpha and beta. So, let me just solve it for you guys to see. Okay, so from here we know that since alpha and beta are the roots of this particular equation, this given equation, it means that if I should sum them up, alpha plus beta is going to give us negative b over a. So that's negative of b is just negative 3, alright? So you know it's going to get to positive. Okay, over a here is just 1. And then we also know that alpha times beta is going to be c over a, which is just over 1, alright? So this is negative 3 over 1, and this is just 4 over 1. So the product is c over a, and the sum is negative 3 over a. That is negative of b over a. So ba is just negative 3. That's going to become positive 3, alright? So let me just simplify that. So this is going to be negative times negative. That will become positive. So I'll just put it down. Positive 3. And 4 over 1 is just going to give us 4. Okay, so given that alpha plus beta is equal to 3, and then alpha times beta is equal to 4. Now we pause there for now. So this is what I would like to do. We have to find the equation whose roots are 1 over alpha squared and 1 over beta squared. So, since 1 over alpha squared and 1 over beta squared are the roots of a certain quadratic equation, right? Equation. It implies that if, let's give a general equation, right? It implies that if x squared minus, okay, let me put a plus bx plus c is equal to 0. So it implies that if x squared plus bx plus c is equal to 0, then let me put this down as a, sorry for that. Then 1 over alpha square, right? 1 over alpha square plus 1 over beta square is equal to negative b over a, and 1 over alpha square times 1 over beta square is equal to C over A. So what I'm just saying here is that if we find a new equation, okay, whose roots are 1 over alpha square and 1 over beta square, the equation should be such that the sum of those two roots, 1 over alpha square and 1 over beta square, will give us B over A, just like we normally have, okay? And the product will give us C over A. So that's just what I'm trying to do here, right? Okay, so I am going to sum these new roots together. Let me use this part. So I'm going to sum these two roots together. 1 over alpha square plus 1 over beta square. I will try to simplify this. Okay, so since this is just the sum of two fractions, we need to get a common denominator. So by that, I'm going to go ahead and multiply these two denominators together. I'm going to have alpha times beta square. You know, the two of them are with their squares. Okay, so we just take a common square like that. And again, I'll multiply this alpha times beta, beta times beta, alpha times alpha. So we're going to have beta square plus alpha square. So kind of taking the LCM and simplifying things. Okay, so from here, I can see from the numerator, alpha square plus beta square is the same thing as, beta square plus alpha square is the same thing as alpha square plus beta square. Let me just write that down as for confidence. Okay, so this is alpha square plus beta square. Now, if we have 1 alpha plus beta and we square that, okay, I want to write an identity for this, so I'm trying to bring it out from here. This is the same thing as alpha square plus beta square plus 2 alpha beta, alright? If you want to expand this, alright, either using binomial expansion or just write it twice and multiply them, this is what you enter with. And if I want to make alpha plus beta square, alpha square plus beta square to stand alone on one side, just like we have it here, I'm going to move this one to this side. So I'm going to subtract 2 alpha beta from both sides. So that means that alpha square plus beta square is alpha plus beta all square minus 2 alpha beta, alright? So in place of alpha plus beta, alpha square plus beta square, I'm going to put this one down, alright? So that is the same thing as alpha plus beta all square minus 2 alpha beta, alright? And I still divide it by what I have in the denominator, alpha times beta square. So that's just the substitution. Okay, so that is going to make our work beta. Now, this is it. We have it here that alpha plus beta is equal to 3. So I'm going to check this out. Where I see alpha plus beta, I just put it 3. And again, we have it that alpha times beta is positive 4. So when I'm going to see alpha times beta, I'm just going to put positive 4. And that's going to simplify things for us. So that will become alpha plus beta is 3. Okay, so I'll just put it down, 3. And I square that minus 2 times here. Alpha times beta is 4 from here. So I'll just put that 4 down. Divided by alpha times beta is 4. And you are going to square that. So 4 square is just 16. So here we have 3 square, which is 9. 9 minus 2 times 4 is 8. So 9 minus 8, that's going to be positive 1. So here is just 1 over 16. As, so it means that 1 over alpha square plus 1 over beta square is 1 over 16. Like that, alright? So that means that the sum of those two roots, the sum of the two roots is just 1 over 16. So how about the product? So we just go ahead and do it for the product. Remember what I said, that the sum will give us the coefficient of x, alright, and the product like just like that. So that means that the product of those two roots, 1 over alpha square times 1 over beta square. So multiplying these two things together, okay, we're just going to have 1 in the numerator divided by alpha square times beta square is alpha square times beta square. And you can rewrite it as this. You just, since the square is common, and every term there is being multiplied together, and they're all perfect squares, so you just put a general square for them, right? Okay, so alpha times beta, again, is 4. So you square that, you're going to have 16. That means that the product is still 1 over 16. And now here is the deal. Since we know from here that the sum will give us negative b over a, and the product will just give us c over a, right? It means that, this implies that the sum of those two roots, 1 over alpha square with 1 over beta square, which is equal to 1 over 16, is equal to negative b over a. So it's equal to negative b over a, right? Okay, so that is it. And we also know that their product, 1 over alpha square times 1 over beta square, is 1 over 16, which is c over a, like that, right? So that is just c over a right there. So since that is the case, it simply means that, if you are equating the fractions, okay, you want to check these things out, you will see that in both cases, the denominator is a, and in both cases here, the denominator is 16. So we can simply say that a is equal to 16, we can say that b is negative 1, and we can say that c is equal to 1. So we're going to use the values of a, b, and c to construct a new equation, right? So let me clean this side. For the new equation, so the new equation now becomes 16x squared minus x plus 1 equal to 0. So that right there is the equation whose roots are 1 over alpha square and 1 over beta square. So you just have it that the sum is negative b over a. So the sum is 1 over 16. That's just negative b over a, right? So you try to equate things together. You see that a is equals to 1. You see that b equals to negative 1 and c equals to 1. So you bring that back into what we know. A takes the place of, as the coefficient of x squared. B takes the coefficient of x, and c takes the constant position. And that is it. Okay, let's move over to the third question. Alright, so from the third question, we have it that the roots of the equation x squared plus px minus q equal to 0 are alpha and beta. Alright, then find the equation whose roots are alpha times beta plus beta and alpha times beta plus alpha. Okay, so just like we did for the second question, we are given a certain equation and we are given the roots to be alpha and beta. Then we are asked to find a new equation whose roots are these, alright? So like we did the other time, we will just identify our a, b, and c, then use the fact that the sum of the two roots will give us negative b over a, and the product will give us c over a, then keep it, and sum these two together, substitute things where necessary, multiply them together and do the same thing, and equate it to, and just bring it back, alright? So let me just put it down that a is equal to 1. We have it that b is equal to p, alright, from this given equation. And again, we have it that c is just negative q, like that. Okay, so since those are the cases, then it will mean that the sum of the two roots of that certain equation, of that particular equation, will be alpha plus beta, which will give us negative b over a. Now look at this. Negative b here is p, alright? A here is just 1, alright? And then alpha times beta will give us c, where c here is just q, negative q, sorry, over a, where a here is just 1, alright? So you can see from here that this is just equal to negative p, and this one is just equals to negative q, just like that. So the sum of those roots is giving us negative b over a. The product is c over a. So that's just it, alright? Okay, so that makes sense. Let me write it straight. Now, we are going to consider the roots, the new roots, the roots of the new equation we are given. By considering the roots, it means that the sum of those roots will give us negative b over a of that new equation, alright? So the coefficient of the x variable divided by the coefficient of the x square of the new equation. So that means that the sum of those two roots, alpha, let me put this down. We are just going to make use of these ones. So this is alpha times beta plus beta plus alpha times beta plus alpha. So we're going to add these two expressions together, alright? So this is going to give us 2 alpha beta plus alpha plus beta, like that. And again, the product, alpha beta plus beta times alpha beta plus alpha. So by multiplying these two together, we're going to have alpha beta square, right, plus alpha square beta plus alpha beta square, then plus alpha times beta. So just try to expand them, and that is what you will get. Okay. From here, okay, let's just put it over this side. So from here, that means that the sum of the two roots, in fact, let me just put it down like this, the sum will give us 2 of something plus something. Now, I'm leaving this space because we're going to have 2 times alpha times beta. Here, alpha times beta is just negative q, alright? So 2 times negative q. Again, alpha plus beta. So here, alpha plus beta is just negative p. So we're going to put it down, negative p. So that is the sum of the roots. So if you want to check this out, we're going to have negative 2q minus p, alright? And again, I'm going to consider the product. Now, let me put a little thing down here. So I'm going to have it to be alpha beta square plus alpha times beta, this one and this one first. If you want to consider this, alright, I'm going to factor something. I'm going to factor alpha beta, and in the bracket we're going to enter with alpha plus beta. So these two expressions here, or these two terms, by checking them out, alright, we'll see that if we factor alpha from each case, here we'll just be left with beta square. Here we just have single alpha left. And if you factor beta, here beta will be gone, and here beta will just remain single. So that's just what I'm doing. So you can check this out on your own, alright? So just get that. So that means that the product is this. Now if you check, alpha times beta is negative q. So we just put it down, negative q, and you go ahead and square that. Then alpha times beta normal without the square. So plus the negative q plus alpha times beta, that is just q, then open bracket, alpha plus beta, that is negative p, alright? Negative p. So here is alpha times beta, which is negative q. Sorry for that. So this is just negative q. Okay, so here I'm going to just simplify this. We're going to have q squared minus q plus qp as the product. So that means that the new equation will now become, now look at this, x squared minus the sum x plus the product equal to 0, right? X squared minus the sum of the roots plus the product of the roots equal to 0. So the sum is now negative 2q minus p, and the product is q squared, right, minus q plus pq is something as qp. Maybe we can simplify this a little bit. We're going to have x squared plus 2q plus p, 2q plus p, then we just put down the x behind them, and again we add it with this here, q squared minus q plus pq, like that, equal to 0. So look at the given equation. Okay, so we have to find the new equation. So this is the new equation whose roots are alpha times beta plus beta and alpha times beta plus alpha. Okay, so let's move over to the fourth question. This was it's simple, though it's a little bit tricky and it's time consuming. You just need to be sure of what you are given, okay, the signs in front, and you use the basic facts and try to establish a new equation with the new roots, okay, given. So knowing that the sum of those roots will give you the coefficient of x, negative of that sum will give you the coefficient of x, and the product of those roots will give you this. So just multiply them, try to substitute the other stuff you found initially, and that will give you, and that will be it, alright? So let's move over to the next question, which is the fourth question. Okay, now if one root of the equation 27x squared plus px plus 8 equal to 0 is known to be the square of the other, find p, right? Look at how the question is that if one root is known to be the square of the other, so suppose we say that let alpha and beta be the root, okay, then by the statement, if one root is the square of the other, so it means that alpha is beta square or beta is alpha square. So one root is gotten by squaring the other roots, alright? So if we have alpha and beta to be the root, it means that either alpha can be written as the square of beta or beta can be written as the square of alpha. Well, without loss of generality, I would just like to pick one of these cases, alright? Any one you pick is actually the same thing, because we only have to compute their sum and their product, so which is commutative anyway. I would like to work with alpha, so I'm going to say let beta be equal to alpha square. Now, since we know from the statement we've gotten to this point, alright, so we just have to know that the sum of the two roots, alpha plus beta, will just give us alpha plus, so let beta be alpha square, alright? So that will be alpha plus alpha square, which is always equal to negative b over a. So I'll just put it down, negative b. Now, what is b from this given equation? B is equal to p, alright? Just looking at it, that means negative p over a. What is a here? A is just 27. So I'll just put that down, alright? I don't need to write them out again. And their product, alpha times beta, will be alpha times, where beta is alpha square, alright? So that is alpha square. So I'm picking this one. I'm working with this. You can still work with this. There is no problem. It's just that you are going to be working with beta, which is just a notation. I decide to just work with alpha, right? Okay, so this is giving us, well, if you just add these two things together, or you multiply these two things together, you're going to have alpha cubed, alright, which is the same thing as c over a. In this case is 8 over 27. Okay, now we can see this as two equations, so let me just write them out. We're going to have alpha plus alpha square equal to negative p over 27. We can go ahead and call that 1. And again, we have that alpha times alpha square, which is just alpha cubed, is 8 over 27. And you can go ahead and call that your second something, okay? Let's say just give it a name 2. Alright, so from 2, we can see that, let me use this space a little bit. So from 2, alright, you can see that since alpha cubed is equals to 8 over 27, we can just make alpha a subject of formula by just taking cube root of both sides, right? So that means that from equation 2, that alpha is the cube root of 8 over 27. And lucky enough, 8 is a perfect cube, gotten from 2 cubed. It's going to give us 8. So the cube root of 8 is going to be 2 over the cube root of 27 is just 3. So that means that alpha is equals to 2 over 3, like that, right? Okay, so since we've gotten that for alpha, Well, if you were to find the other root, it means the square of that will give us beta, which will just be 4 over 9. But that's not what we have been asked to do. So we have to go ahead and find the value of p, which is just the coefficient of x. So from this equation 1, alright, we have something with p, so we can easily make use of that. Okay, so since we know that alpha plus alpha square is equals to negative p over 27, so let me just make a little statement. Since alpha plus alpha square is negative p over 27, where alpha is 2 over 3, it means that 2 over 3 plus 2 over 3, then we square that, alright, is negative p over 27, given that alpha is 2 over 3. So this is just a very simple algebra to deal with. This is going to give us 2 over 3 plus 4 over 9. You know, by just squaring this, that's what you get, which is negative p over 27, like that, alright? Okay, just a straight line. Well, I would like to sum up the fractions on the left-hand side. So by summing them up, I will need a common denominator, and I'm just going to do it by multiplying this other fraction by 3, alright? And multiply this with 3. Alright, so I'm going to have 6 over 9. 6 plus 4 is 10, alright? So I'm going to have the 10 over 9, like that. This is 12, 18 plus 12, that is 30 divided by 27, okay? Alright, sorry for that. So this is just equal to negative p over 27. Alright, so from here, I would like to just multiply both sides by 9, alright? I want to make p subject of formula actually. So you can work this your own way. You know the steps, you know what is necessary. So my own way, I would like to multiply both sides by 9. I'm going to have 9 here, 9 here, and 9 here. I know that this will cancel out with this one nicely, and we'll just have 10 on the left hand side, and here this will cancel out with this one, and we'll just have 3 here. So that means that 10 is equal to negative p over 3. So multiplying both sides by 3, we're going to have that negative p is equal to 30, which means that p is equal to negative 30. So that is the value of p. The question was to find p. So by doing all this little mathematics, we've seen that p is negative 30, and that is it. Okay, so let's move over to the 5th question.